This video is on the objective find the z-score given the confidence level. And this is number 1, so this is the first video I'm doing on a question related to this objective in your Newton Alta homework. Right, so again, I say every video here, if you're unfamiliar with the objective, please click on More Instruction and take a look at that, look at their notes and their videos and examples, and hopefully that'll help. So let me just go through this here in my own way. Alright, so suppose the number of defects in a sweater from a population of sweaters produced from a textile factory are normally distributed, with an unknown population mean and a population standard deviation of 0.06 defects. So a random sample of sweaters from the population produces a sample mean of 1.3 defects. Right, what value of z should be used to calculate a confidence interval with a 95% confidence level? All right, so again, I'm going to go to some paper and write out what's the situation here, describe what's happening, and what we're trying to find. Okay, so I have this population of all these, these sweaters produced in some textile factory. Right. So I have a population of sweaters in this factory. And say X represents the number of defects in a sweater. Number of things wrong with it, right? Alright, so what we're told about X, what we're told about this number of defects in the sweaters in this, all the sweaters, right, the population of sweaters in this factory, we're told that X is normally distributed with some mean, mu, and some standard deviation, sigma. Where mu, the average number of defects for all the sweaters in this factory, is unknown, right? And it should be unknown. Usually it's unknown because we're going to try to guess what it is. Right? We're going to try to get a reasonable. We're going to try to guess in what range of values is the average number of defects. That's what a confidence interval is. It's an estimate of the population mean, or the population proportion, or some population parameter. And we are told that the standard deviation of the population of all these sweaters in this factory is 0.06 defects. Alright, so then from this population, we pull a sample of n sweaters. Now, they didn't tell us how big a sample was pulled here. A sample of n sweaters. And take the, the mean number of defects of that sample. And they told us for this particular sample we're looking at, the x bar, the sample mean, was 1.3 defects per sweater in this sample of n sweaters. So the variable, again, imagine you could take all possible samples of size n and look at the average number of defects in all possible groupings of n sweaters. That's what this variable x bar will represent. The average number of defects that's an F. The average number of defects per sweater for groups of n sweaters. For groups of n sweaters. Let's say for groups of n. Now, by the central limit theorem, right, because the population was normal, no matter what size sample I took, the distribution of the means, all these x bars, would be normally distributed with a mean of mu x bar and a standard deviation of sigma x bar. And the mean of the means, the mean of these x bars would be the mean of the population. But again, this is unknown. So instead we use 1.3. We're going to use our x bar as a point estimate. And the standard deviation of these x bars is the standard deviation of the population divided by the square root of the sample sizes. Now we don't know what this, this is going to be 0.06 divided by the square root of, I don't know what n is, but that's neither here nor there. This is just setting up how we would go about finding a confidence interval. And I'll draw a little picture. There's a number line representing different possible values of x bar. These means for samples of size n. It's normally distributed, right? Bell shape, symmetrical bell shape. Where the middle here, right, under the peak, we have our mean. Now again, mu I don't know, but I'm going to use the point estimate, the sample mean 1.3. Right, and what we're looking for, I'm looking for two values, one above the mean and one the same distance below the mean, so that our confidence level is the area under the curve, right? They said we have a 95% confidence level in this particular problem. 95% confidence. So that means I'm looking for, again, a value above the mean, which will be at 1.3 plus, some margin of error. And then the same distance on the other side, 1.3 minus this margin of error. And I'm looking for these two values so that the area in between them, under the curve, is my confidence level, right? The area is 95%. Now, if the area that I'm looking at is 95%, the area outside this is 5%, and that's the alpha that keeps getting brought up if you're reading the book and you're reading the more instruction and whatnot. This value called alpha is referred to sometimes as the significance level. And it's just the area left over. So if the confidence level is 95%, the value of alpha is 5%, or as a decimal, 0.05. And if there's 5% left, that means this area here above this upper value in my confidence interval is 2.5%, or 0.025. And the area below is also 0.025. The area below this lower value in my confidence interval. So when I go to find the margin of error, how far above and how far below are these two values? I need to know a z-score. I want to know how many standard deviations, how many of these standard deviations am I above the mean and below the mean? So that's where the z-score comes in. So it'll be some z-score, and then there'll be a subscript on it. And that subscript is this area above. It's the area to the right, this half alpha, 0.025. So again, this is z with a subscript of half of alpha. Right? And then times the standard deviation of the x bars. Right? But this is what they're talking about in this particular problem. They just want to know, if you were trying to calculate this margin of error and figure out our confidence interval here, our 95% confidence interval estimate for mu, what z-score would be needed. All right, so now I'll look back at my chart. Say I need this z-score right here. Z with 0.025 as a subscript. Right, the z-score with 2.5% above it. So these values on my picture are 1.96 standard deviations away from the mean. So here's 1.3. This upper value of the interval would be 1.96 standard deviations, 1.96 times whatever this standard deviation is above the mean. And then this value would be 1.96 standard deviations, or again 1.96 times whatever this standard deviation is below the mean. But the z-score we would need is 1.960 there. And that's what I'll enter. That's all that's being asked. 1.960, submit. and fantastic. Okay. So you see they talk about this alpha, 1 minus the confidence level. You know, you got this z with alpha over 2, you cut alpha in half and then look at the proper value on this chart. Okay, wonderful. And I don't think there's a second part to this. No, there isn't. So hopefully that helps with a problem like that. And thank you very much for watching.